Have you ever just stopped and wondered how a massive mountain or a super deep canyon actually got there? Well, the surface of our Earth isn't static at all. It's more like a masterpiece that's constantly in progress, being shaped by these incredibly powerful forces. In this explainer, we're going to dig into the story of how our world gets its shape, drawing straight from the Class 11 NCERT chapter on landforms and their evolution.
It really all starts with a pretty simple question. If gravity is always pulling everything in, why aren't we living on a perfectly smooth ball? I mean, what kind of powerful forces are out there working against that, creating all the incredible mountains, valleys, and plains that make our world what it is? Well, that's exactly what we're about to find out.
So, here's our game plan. First, we're going to look at the big picture forces that shape our planet's surface. Then, we'll dive into the amazing sculpting power of rivers, explore the hidden world of groundwater, and really feel the immense force of glaciers. And finally, we'll bring it all together to understand our ever-evolving planet. Let's get right into it.
All right, our first section is all about the fundamental forces at play. You can almost think of the Earth's surface as this giant canvas where a constant battle is being fought.
So, the most basic building block of any terrain is what we call a landform. It's really just a piece of the Earth's surface. It could be a hill, a valley, a sand dune. Each one is its own distinct feature.
And when you kind of zoom out and put a bunch of related landforms together, what you get is a landscape. Think about a mountain range. You've got the peaks, the valleys, the ridges. That's a perfect example of a landscape. It's a whole collection of individual landforms creating a bigger, more complex picture.
And the creation of any landscape really boils down to this constant struggle between two opposing forces. From deep inside the Earth, you have these internal forces. We're talking volcanoes and tectonic uplift that are always building up the surface. But at the exact same time, you've got external forces like wind, water, and ice that are working non-stop to wear it all down. This epic tug of war is literally what shapes the world that we see around us. So, how in the world do we make sense of changes that happen over millions of years? Well, geographers use this brilliant analogy. They see a landmass as going through stages of development, a lot like a life cycle, with a youth, a mature phase, and an old age. This idea is really the key to understanding everything else we're about to cover.
So let's see that whole life cycle idea in action. We'll start with one of the most powerful external forces on the planet, running water. In so many parts of the world, rivers are, without a doubt, the main artists sculpting the land. I mean, just look at the sheer, raw power of running water. This canyon, carved out by the Colorado River, shows you exactly what's possible. Over millions of years, the non-stop flow of water has just sliced right through solid rock, creating this huge step-like landscape. This is erosion on a truly epic scale. And this whole process follows that life cycle we talked about almost perfectly. A young river is fast, it's energetic, and it cuts straight down, carving out these steep, V-shaped valleys and creating dramatic waterfalls. As it gets more mature, it starts to erode sideways, which widens its valley into these broad floodplains. And by its old age, the river is just meandering slowly across a huge, flat landscape. Its major work just about done.
Okay, so we just saw that incredible canyon a moment ago. But you've probably also heard of a gorge. So what's the difference? Well, it really just comes down to the type of rock and the shape it ends up with. Gorges tend to form in really hard, resistant rock, which creates these deep valleys with super steep, almost parallel sides. Canyons, on the other hand, are often carved in softer, layered rock. They're also deep, but they have those very distinct step-like slopes and are way wider at the top.
Now, in a river's old age, it starts to get really loopy. The water is eroding the outer bank of a curve while it's dropping off sediment on the inner bank. And over time, these loops just get more and more extreme, until finally, the river takes a shortcut, cutting the loop off completely and leaving behind this really cool crescent-shaped oxbow lake. All right, so we've seen what water can do on the surface, but what about all the water that's flowing right under our feet? Let's go explore the hidden world of groundwater and the strange, really beautiful landscapes it creates. Welcome to the world of karst topography. This amazing landscape you see here, inside a limestone cave, it wasn't carved by brute force. No, it was created by a quiet chemical reaction. You see, rainwater is naturally a little bit acidic, and it just slowly dissolves soluble rocks like limestone, creating this incredible subterranean wonderland. So this process creates a landscape that has, like, two faces. On the surface, water seeps down through cracks and dissolves the rock, forming sinkholes. But below the ground, that very same water is carving out these vast networks of caves.
Everything is connected, from the openings on the surface right down to the hidden chambers deep underground. And inside these caves, we find two totally iconic formations. Here's a super easy way to remember them. Stalactites hold tight to the ceiling, while stalagmites might one day reach the top from the ground. Both of them are built drip by drip over thousands of years from mineral deposits. And sometimes they even meet in the middle to form a huge pillar. All right, on to our final sculpting agent. And believe me, this one is a powerhouse: ice. Glaciers are pretty much just rivers of ice, moving incredibly slowly but with this immense power to erode, all because of their sheer weight and the rocks they're dragging along. This is basically what a landscape looks like after a glacier has passed through. The incredible weight of the ice just carves, plucks, and scrapes the land, leaving behind this really unique collection of features, from super sharp peaks to wide-open valleys, which we're going to look at more closely right now.
Glaciers leave behind some of the most dramatic landforms you'll ever see. They scoop out these bowl-shaped basins called cirques right at the heads of valleys. Where two of those cirques erode back to back, they form a razor-sharp ridge called an array. And when several cirques just eat away at a single mountain, they create a sharp pyramid-like peak called a horn. The famous Matterhorn is a perfect example. And of course, they turn those V-shaped river valleys into wide, flat-bottomed, U-shaped valleys.
The glaciers don't just take things away, they also leave stuff behind. As a glacier melts and retreats, it just drops all the rock and junk it was carrying. This jumbled up material forms these long ridges called moraines, and they act almost like geological fingerprints, marking the exact edges and the farthest point the ice ever reached. So, we've journeyed from raging rivers to silent caves and massive glaciers. Let's try to bring it all together and think about what this constant, unending change really means for our planet.
You know, if there's one single thing to take away from all of this, it's that the ground beneath our feet is not permanent. The face of our planet is a dynamic, living story that's constantly being written and rewritten by the relentless forces of water, ice, and the almost unimaginable sweep of geological time.
And that brings us to a final, really important thought. For billions of years, natural forces have been writing Earth's story. But today, there's a new force out there, reshaping the planet at a speed we've never seen before: us, humanity. So it leaves us with a pretty critical question. What are going to be the defining landforms of this new human age?